Welcome back, everyone. In this video, we are going to continue our lesson on Chapter 1 of the Stanley Baronet textbook, which is about the structure of arguments, right? The key topic, really, of all of logic. So in the last videos, we looked at the main ingredients of logic, the main ingredients of an argument. Arguments are positions which build off of premises in support of a conclusion, right? We talked about each one of those ingredients in turn. Premises are statements that have a truth value. Conclusions are offered up in support of those, the conclusion is said to follow from those premises. And then we looked at two different branches of argument, deductive arguments on the one hand and inductive arguments on the other. We really spent most of our time looking at deductive arguments, and if you recall from the past video, the key property of deduction is validity. Valid arguments are arguments where it is impossible for the conclusion of an argument to be false when the premises are true, right? So that's really our technical definition of validity, and we kind of explored some of the ways in which we can go about proving whether or not a deductive argument is in fact valid. And we explored the method of substitution or counterexample, which involves formalizing the content of an argument by using, first, reducing the content to symbolic notation, and then substituting out that content for different terms in the premises to see if we can generate a conclusion that is false with the same premises. So in this video, we're going to explore a little bit further another property that I introduced last time, namely soundness. The idea of soundness is related to deduction, but it is a little bit different, or it is really a different criteria of deductive arguments. Soundness refers to a few different traits. Whoops. I'm going to have to shrink myself here. Sound arguments refer both to validity, that is, the structure of the argument in which it is impossible for a conclusion to be false given true premises, but it also refers to truth value. It brings together validity and truth value. And if you have a sound argument, it means the premises really are true and the conclusion is also true. So it's a somewhat higher standard of stringency than mere validity. Validity can occur when we have false premises, believe it or not. Okay, so we sort of looked at this example in the last video, but I'm just going to return to it because it's pretty simple. If I have an argument like this three-parter, we begin with the premise, all beagles are dogs. The second premise says all dogs are mammals. And then we have a conclusion as indicated by our nice horizontal line, all beagles are mammals. So last time we explored the formal structure of this argument by formalizing the content using symbols simply to notate the parts of the premises. Now we're going to have a look at soundness, which asks us to consider whether or not these premises are in fact empirically true, right? So this is a sound argument because each premise and conclusion is true, right? Beagles really are dogs, dogs really are mammals, and so therefore all beagles really are mammals. As I mentioned in the past video, we're not going to be spending really all that much time on truth value analysis because the central concern of logic is not so much questions of fact and questions of accuracy, but more so formal structure. However, it is worthwhile noting that a valid sound argument is one where we bring together the criteria of validity and the criteria of truth value. Indeed, this argument satisfies both validity and truth value. Okay. So if we formalize the argument again, if we kind of treat B as a stand-in for beagles and D as a stand-in for dogs, we have the first premise, all B are D. And then we treat M as a stand-in or a symbolic sort of note or sign for mammals. Our second premise says all D are M. And please just write down for yourself what the conclusion would be with this formalized notation system. Just follow along our initial conclusion. You should have all B are M. Okay, and so like last time, we substituted out the content, beagles, dogs, and mammals, with new content in order to see if we could generate a counterexample where we could come up with a false conclusion given true premises, and we found that we could not do so. So I want to have a look at another example, just starting with formal premises rather than content-based premises. If we have a premise like this, no CRB, and then we have second premise that looks like this, no CRS, we then have a conclusion like this, no BRS. Okay, so when we have an argument like this where we don't have any content at all, it's of course going to be impossible for us to think about whether or not the conclusion is true or false, given the premises, because we have no way of evaluating the truth value of the conclusion, right? And so in such a formal case, we might have to supply the formal structure with content in order to see if there is validity here. This turns out to be an invalid formal example. In other words, it doesn't work as a deductive argument, because we can, if we try hard enough, supply some content that generates a false conclusion with true premises. So let's generate some content that begins with the same formal structure and with premises that are true. So if we swap in the word crocodiles for the symbolic note C and the word boas for the symbolic note B, we begin with premise 1, no crocodiles are boas, and then we swap in for letter S, the content snakes. Premise 2 looks like this, no crocodiles are snakes. Our conclusion now, I want you to sort of try to intuit now from the example in the formal setup here in the first box, should look like this. No boas are snakes, right? No BRS becomes no boas are snakes. So have a look at each premise here and evaluate the truth value of each premise. No crocodiles are boas, that is true. There is no crocodile out there that is also a boa. And then premise 2 also seems to be true. No crocodiles are snakes. It's a different animal altogether. And yet we're generating a conclusion, no boas are snakes, which is false. Boas are snakes, right? So it is possible with this formal structure to generate an argument that has a false conclusion in terms of its truth value with premises that are true in terms of their truth value. So this can't possibly be an invalid argument. And this is interesting because no matter what the content is, this argument still, formally speaking, is invalid. It is not a deductive argument that really proves what it is setting out to prove. Okay, so this is how we're going to deploy the counterexample method to test for validity. Now I want to talk about some of the properties of inductive arguments, and this is discussed in section G of chapter 1. Remember that we are separating out the two large genres of argumentation in the chapter: deduction, which is said to have arguments in which the conclusion follows with necessity from the premises. In other words, it is impossible for conclusions to be false where premises are true. That's the definition of validity in the case of deduction. But induction is a different structure of argumentation, which doesn't make that kind of ironclad guarantee that the conclusion will be true given true premises. Rather, induction appeals to the likelihood of a conclusion being true given true premises, but not the absolute necessity of the truth of that induction. With that being said, there are degrees of strength with respect to the likelihood of conclusions in induction. Some inductive arguments are very strong, and some are much less strong, if not weak. So I want to explore what that would really mean. So logical analysis tells us whether an inductive argument is strong or weak. Try to imagine for yourself what that would mean. What is a weak inductive argument? If I'm telling you that an inductive argument is one where we are appealing to the likelihood or the probability that a conclusion to an argument is true from true premises, but not the necessity of its truth, what might it mean to say that that conclusion is weak? A strong inductive argument is one where true premises are offered in a way that makes it very, very probable that the conclusion is true. It is a high degree of probability. It is a high degree of likelihood that the conclusion is true. So strength is a qualitative property of induction. It refers to the likelihood of the truth of a conclusion. Notice it is not referring to the logical necessity of the truth of the conclusion. That is a property of deductive arguments alone. Induction can never offer up that kind of certainty, that kind of necessity, in the same way that deductive arguments can. Nevertheless, there can be very strong inductive arguments. A weak inductive argument, on the other hand, is one where we have true premises, but the conclusion is still very improbable or very unlikely or very difficult to believe. So notice there are degrees of strength and weakness that are very qualitative and require some experience of the subject matter that the argument is referring to, and require some degree of judgment in terms of being able to assess and evaluate the probability or the likelihood of the truthfulness of that conclusion. So as I've been mentioning in previous videos, induction is a much kind of fuzzier and vaguer version of argumentation, perhaps, than deduction, where we really have conclusions offered up with logical necessity. The inferential chain of reasoning that leads from premises to conclusions is airtight, and when the argument is valid, cannot be false. Induction is never that airtight, is never that certain, but unfortunately a lot of our arguments in everyday life have to rely on induction because the outcome of a certain state of affairs may not be certain, right? And so we're going to explore some examples where that might be the case. So how do we analyze induction for strength and weakness? Let's have an example of an inductive argument. If I begin an argument with premise A, an opaque jar contains exactly 100 marbles. Okay, you could probably hear that this is going to be a kind of a statistical argument. And then I say in the next premise there are 99 blue marbles in the jar. And then I offer up another premise. There is one red marble in the jar. Okay, so now we have a kind of a snapshot of some jar with 100 marbles, 99 of which are blue and one is red. So we have an understanding of the distribution of blue and red marbles. And then the conclusion is the marble picked is blue. So it's kind of making a prediction about a certain event that is said to transpire in the future. So ask yourself, is this a strong or weak inductive argument? Is the conclusion offered here likely to happen, or is it very unlikely to happen? You should know that this is a strong argument, right? Or it's at least a pretty good prediction of what will likely occur just based on the statistics, right? So you don't really have to know that much about statistics and probability to make a pretty sound judgment about the likelihood of the conclusion. But note that the conclusion is not guaranteed. It is not following with necessity from the premises. It is still possible to pick the red marble. It is just very unlikely that you will pick the red marble. Okay, so this argument is purely probabilistic, right? Okay, let's look at another example. An opaque jar contains exactly 100 marbles. Okay, we have the same scenario. And we now are going to tweak things a little bit. In the next premise, we find there are 99 blue marbles in the jar. And then we have the premise, there is one red marble in the jar. Okay, so identical information as the premises offered in the previous argument. But our conclusion will say, the marble picked is red. Okay, so now I ask, is this a strong or weak inductive argument? If you picked weak, you are correct. You are getting this, right? The conclusion here is very unlikely. Statistically, it is possible for the marble pick to be read, but it is not likely. Okay, so these are just kind of probabilistic arguments that really are just offered up to demonstrate that inductive arguments are sort of geared towards the likelihood of events. But notice that nothing is offered in logical necessity regarding that conclusion, right? This is not a deductive argument in which the conclusion cannot possibly be false. It could be false, right, under certain scenarios. Okay, so inductive arguments are increasingly going to be or decreasingly objects of interest for us because we can't really do as much with them as we can with deduction and the properties of validity that allows for all that interesting formalization and substitution and testing of the relationships between the premises and the conclusion. Nevertheless, though, you should understand some things about induction, like soundness or strength and truth value, because a lot of our arguments in everyday life and critical reasoning are really inductive in character. Now I want to talk about another property in addition to strength and weakness, which is cogency. Cogency refers to whether or not an inductive argument is cogent or uncogent. Sorry, little repetition there. What this refers to is the idea that the argument is both strong, i.e. the conclusion is probable, and the premises are true. So cogency is kind of bringing together strength, i.e. probability of the truth of the conclusion, with the truth value of the premises. Okay, so cogency means that we have true premises and indeed that conclusion is strong. It is likely to occur as a factual or statistical event. An uncogent inductive argument means the argument is weak, i.e. the conclusion is unlikely, and it has at least one false premise. Usually uncogent inductive arguments are complete train wrecks of reasoning, right? They make little sense. They offer up unlikely events, and then they're referring to things that aren't even factually true. So an uncogent argument is weak, that is unlikely, and has factually untrue premises, at least one factually untrue premise. Okay, so these are some of the properties of inductive arguments. Strength refers to the likelihood of the conclusion being true. Cogency brings together strength and weakness, i.e. probability, with the truth value of premises. All right, so just to move on and kind of recap a little bit here where we're at. We're sort of taking in a lot of new terminology here, so it's good to just retrace our steps. Deductive arguments are either valid or invalid. That's really the key criteria that we're going to be investigating with respect to deduction. Validity refers to the idea that conclusions are necessarily true given the truth of premises. When an argument that is deductive is valid, it means that the formal structure of the premises relates to the conclusion in such a way that it is impossible for that conclusion to be false, right? It is impossible for that conclusion to be false. There are invalid deductive arguments out there, however, there are plenty of them, and arguments are invalid when it is possible for that conclusion to be false given true premises. Okay, so deductive arguments are valid or invalid. Deductive arguments are either sound or unsound. Remember, soundness brings together validity or formal structure with truth value. And what this means is that a deductive argument either has true premises or untrue premises, right? That's really what soundness is referring to. And all invalid arguments are unsound. All invalid arguments are unsound because the conclusion will be false, okay? Or the reasoning process underlying the relationship between premises to conclusion will be invalid. Okay, so deductive arguments refer to validity or invalidity. and soundness or unsoundness. Inductive arguments are either strong or weak. We're not thinking about validity or invalidity when we're dealing with induction. We're dealing with strength and weakness. Validity is a different property, and it only refers to arguments of a deductive kind where the conclusion is said to follow with necessity from the premises. Inductive arguments only make appeals to the likelihood of a conclusion being true on the basis of true premises. Strong inductive arguments are either cogent or uncogent, and cogency refers to not only the strength of the argument, but also the truth value of the premises. Cogent arguments are ones where we have a high likelihood of the truth of the conclusion, and all of the premises are indeed factually true. All weak inductive arguments, however, are uncogent. All weak inductive arguments are uncogent. There cannot be such a thing as a strong, uncogent argument. Okay, and we won't really encounter all that many weak, uncogent arguments in our examples, but it's worth knowing what they mean. Okay, so let's have a look at some examples. Try to write these down with me so that we can kind of work slowly together and start to get a grip for these different terms that we're piling on now. So if we have an example like this, most politicians are liars. Madison is a liar, thus she is a politician. Okay. You'll notice this is an inductive argument, right? That word most is kind of an indication of induction. It's referring to probability or likelihood. But think about whether or not this is a strong or a weak inductive argument. Most politicians are liars. Madison is a liar, thus she's a politician. This is weak. The reason it's weak is because even if the premises are true, they don't seem to support the probable truth of the conclusion. In other words, something is a little off or a little wonky about the relationship of the premises to this conclusion. These premises don't really give us enough of an account of who Madison is such that we could conclude she's a politician, right? There's too much open-endedness in this induction for it to count as a good inferential lead. Let's compare this argument to a revised version. If I say most politicians are liars, Madison is a politician, thus she is probably a liar. Notice we're still in the genre of induction. I'm using words like probable and most, so the conclusion, thus she is probably a liar, is not saying she's definitely a liar. It's saying she is in all likelihood a liar, right? So then I ask you, is this strong or weak? This is an example of a strong inductive argument. It's strong because the premises have given us enough information to kind of infer that this figure, Madison, is probably a liar. Now, the conclusion is not saying Madison is definitely a liar, right? This would be kind of an invalid, or really this would be kind of sort of a hybrid of deduction and induction that wouldn't make much sense, right? So this argument is the litmus test for it to be strong doesn't include certainty that Madison is a liar. It only is pointing to the likelihood that Madison is a liar. So we don't actually have to know with certainty that this argument is true. We just have to know that it's reasonable to expect it to be true. Okay, this is a very busy map of our different types of arguments here. I'm going to make this available to you so you can refer back to it. But this tree is intended to kind of schematize the different types and properties of arguments that we've explored so far. Okay, so we're beginning with arguments, which is the key topic of logic. And we have learned so far that arguments are either deductive or inductive. Deductive arguments are either valid or invalid. Valid deductive arguments are ones where the conclusion cannot possibly be false given the truth of premises, and invalid deductive arguments are ones where it is possible for the conclusion to be false given true premises. Valid arguments are either sound or unsound. Sound, valid, deductive arguments are ones where you have validity, you have a formal structure that works, and indeed, factually, all of the premises are true. So soundness combines validity with truth value analysis. Unsound deductive arguments are ones where the premises are not true. Okay? All invalid arguments are also unsound. With respect to induction, inductive arguments are either strong or weak. Validity is not a property of induction. So when we're dealing with induction, we're dealing with strength and weakness. And strength means the likelihood of the truth of a given conclusion, and weakness refers to the lack of probability or the low probability of a given conclusion. Strong arguments are either cogent or uncogent. Cogent means that all of the premises are true, so cogency brings together probability or strength with the truth value analysis of the premises. And weak arguments are always uncogent. Weak arguments, which are probabilistically low, will have factually incorrect premises. Okay, so this is a map of our core concepts for chapter 1 in terms of the many genre of argument and the different things that differentiate the properties that we'll be exploring. I am not expecting you to really memorize this map in terms of being able to say exactly where every property falls on the map, but I do want you to become well oriented with the kinds of things it is that we're exploring when we're looking at, for example, a deductive argument and exploring whether or not it's a valid deductive argument, as opposed to exploring an inductive argument and asking whether or not it's strong or weak. So as we work on more problems and examples, I think that skill will develop over time. This is just a reference for you to check back on if you feel lost at sea, as it were. You have no idea anymore what deduction and induction is, but don't think of it as something you have to be able to rattle off independently of an example. Okay, so in the next lessons, we're going to be exploring a little bit more some of the properties of validity, and really we're going to work on formalizing our arguments so that we can test for validity through the substitution method. Thanks, everyone. See you next time.